Hello students, let's see the graphical method for angle criteria, and second is the graphical method for finding k, that is constant at a point. Okay, see in previous lecture we have seen angle and magnitude criteria. So we know that for angle criteria, angle should be plus minus 180 degree, and magnitude criteria is mod of g of s h of s is equal to 1. Okay, so that we have calculated analytically. Now we will see the method to calculate angle criteria using graphical method. Okay, so see, we will take same example that we have taken for the analytical purpose. Okay, so that we can cross verify whether we are getting same answer or different answer. Okay, so in previous lecture I have taken g of s h of s is equal to k upon s plus 2. Okay, so if you remember, we have taken 2 points, s1 is equal to minus 1 plus j, and we have taken second point, s2 is equal to minus 2 plus j. Okay, so in that we know that the first point s1 is equal to minus 1 plus j is lying on root locus because it is satisfying angle criteria, whereas we have calculated angle criteria for second point, that is s2 is equal to minus 2 plus j, but it is not satisfying angle criteria. So we have concluded that point S2 will not lie on root locus. Okay, so here as I know that point S2 is not lying on root locus, so I have taken only one point, that is S is equal to minus 1 plus j. Okay, and in that we know that the point S1, when we have taken minus 1 plus j and we have applied angle criteria analytically, so we got the angle as minus 180 degree, and we have concluded that the point S1 will lie on root locus. Okay, now here we need to cross verify using graphical method whether we are getting same or different. Okay, so let's see now what I did here. Here transfer function is given. So see here, this is actually sigma j omega axis. Okay, so I know that the characteristic equation is nothing but the denominator, or when I will equate this denominator to 0, I will get number of poles. Okay, so in this transfer function, two poles are there. First pole is at, when you will equate, you will get s is equal to 0. So see here, I have shown the pole at origin, that is at s is equal to 0. Okay, and second pole is a real pole. When I will equate, I will get s is equal to minus 2. Okay, so see here, I have shown s is equal to minus 2. Okay, so I have plotted this transfer function in s domain. So this is my s domain with the number of poles at s is equal to 0 and s is equal to minus 2. Okay, so now what I need to do, I have to recheck using graphical method whether this point s is equal to minus 1 plus j will lie on root locus or not. Okay, for that, see what is the formula that we are using for graphical method. So look at this, summation of angle subtended, this is angle subtended by zeros minus angle subtended by poles. Okay, summation of angle subtended by zeros minus summation of angle subtended by poles. Okay, is equal to plus minus 180 degree at that point. What is that point? Point is actually s is equal to minus 1 plus j, or in short I can write the formula summation of angle subtended by zeros minus summation of angle subtended by pole should be plus minus 180 degree. Okay, at that point. So what is that point? Point is actually s is equal to minus 1 plus j. Okay, so what I will do, I will show the point s is equal to minus 1 plus j in s domain. So see here, this is minus 1 plus j, this is actually the complex root. Okay, so minus 1 plus j. So I have shown here s1 is equal to minus 1 plus j. Okay, now what I will do, I will join all the poles with this point, and if zeros are present, I will join all the zeros with this point. Okay, in this transfer function no zeros are there, only poles. Okay, so see what I will do, I will join the pole at s is equal to 0 with this point s1. See here, I am joining this with point S1. Okay. Now second, again I am joining the second pole with the point S1. Okay. So what I need to do, I have to calculate angle subtended by 0. Is there any 0 here? No. So what I will do, I will write here angle subtended by 0 is equal to 0, because no zeros are there. Okay. Now I will check angle subtended by poles. Okay. So how many poles are there? 2 poles are there. So I will calculate the angle subtended by poles with the point that we are considering, and this point is actually -1 plus j. Okay. So see, for that I am considering the positive x-axis. So my reference is positive x-axis. Okay. So see what I will do now. I will calculate the angle subtended by this pole with the point. Okay. So look at this. When I will join this with the dotted line. See here. Okay. So what I am getting here, I can calculate the angle here. See here. This x is 1 and y is also 1. So hypotenuse it will be √2. Okay. So definitely see here, this angle, this is actually 90 degree. Okay. And again I will add there 45. So what I am getting here, I am getting here 135 degree. Okay. So angle subtended by this pole with this point is 135 degree. Okay. Now see here, angle subtended by this pole with this point. Okay. So see here, again this is actually the one I am considering this triangle. Okay. So this is actually 1 and this y-axis or y coordinate is also 1. So again I am getting here √2. Okay. So see how much will be the angle subtended. Here it will be 45 degree. Okay. I hope you are getting. This angle subtended by this pole with this point is 135 degree. Angle subtended by this point with this S1 is 45 degree. Okay. So summation of this P is 135 plus 45 is actually 180 degree. Okay. So I will put in this formula that summation of angle subtended by 0 minus angle subtended by pole. So this will be 0 minus, see here, this is 180 degree addition. Okay. So what I am getting here, I am getting minus 180 degree. Okay. See, we are getting same thing. Okay. We have considered same point, same transfer function, and we got same answer with graphical method also. Okay. So what I will say, as it is satisfying angle criteria, so point S1 will lie on root locus. Okay. See here, I have written that we have to check whether point S is equal to -1 plus j will lie on root locus or not. Okay. But as we got angle as -180 degree, so that point S1 will lie on root locus. Okay. So this is graphical method for calculating angle criteria. Now see, the second method is graphical method for finding K. So what is K? K is a constant. Okay. At a point. At a point means again the point is given. Let's assume that the point is same point that I have taken as S is equal to -1 plus j. Okay. So for this point I have to calculate the value of constant, that is K. Okay. So what is the formula? See here, product of phasor length of poles to the point. Product of phasor lengths of poles to the point. To the point means S is equal to -1 plus j. Okay. So in numerator now product of phasor length of poles are there. See, this is poles. Upon product of phasor length of zeros to the point. Okay. So see, I hope you got the formula, and this is transfer function, the same transfer function I am considering, and I am calculating K for the same point, that is S is equal to -1 plus j. Okay. So see what I did here. Here again I have shown this transfer function. So this is my transfer function. Okay. See how many poles are there? 2 poles at S is equal to 0. So this is first pole at origin. Second is S is equal to -2. So second pole is at -2. Okay. So what point I am considering? I am considering the point S is equal to -1 plus j. Again the same thing. See here, -1 is a real part and plus j is imaginary part. Okay. So this is my point. Okay. So what I will do, again I will do the same thing. I will join all the poles with the given point and I will join all the zeros with the given point. But in this transfer function, as zeros are not there, so no need to show. So what I will do, I will join the first pole with this point. Okay, so see, I need to calculate a phasor length. So how much is a phasor length? See, here I am showing it with the dotted line. So this x coordinate is actually 1, y coordinate is actually again 1. So how much is the phasor length? This is actually root 2. Okay, now see this second thing. The second pole is at s is equal to minus 2. I will join this s is equal to minus 2 with the given point, that is s1. I am taking minus 1 plus j. Okay, so see here, so this is actually phasor length. So again I am considering this triangle, I am considering this small triangle. Okay, so see here, actually x coordinate is 1, y coordinate is 1. So how much is the phasor length? Is root 2. Okay, so see, product of phasor length of poles to the point. Two poles are there, so 2 phasor length. How much I am getting? I am getting root 2 and root 2. I am getting root 2 and root 2. Okay, product of phasor length of zeros. Zeros are not there. In that case, we will consider 1 only. Okay, so see what I am getting. I am getting root 2 into root 2. It will be 2. So I am getting k as 2. I am getting k as 2. Okay, so this is actually the graphical method for finding constant k. See, we have seen both the methods, analytical method and graphical method. Okay, so you can select any one for calculating the value of k and for calculating the point s1. Okay, thank you students.